Let's look at another example. For this given composite area, we are looking for the centroid of it. And those pieces or segments are already labeled. In other words, this composite area are already divided into 4 simple shapes. So we have A as a triangle, B as a rectangle, C is the quarter circular. So here, since we're treating B as a rectangle, that means we're including this corner, which originally was a hole here. And for C, is a quarter circle as well. This actually the corner was a hole originally. So therefore, we have to subtract the semicircular area D. So note that a negative sign should be used for the table for this semicircular area D, which is the hole. So we're gonna make a table again, but before we make the table, let's write down the formulas that we're gonna use as a guideline to see what values should we put into the table. So we're looking for the centroid of this composite area. So the centroid will be equal to the sum of x tutor A, the area of each segment, over the sum of the area. And this is a 2D problem since we're looking for the centroid. So we only need to find x bar and y bar. For y bar, it will be y tutor times A over sum of A. So that means we need to find first column will be the segment. We have A, B, C, and D. And we need to find the area of each segment, and we need to find x tutor, y tutor of each segment, and then calculate x tutor A, y tutor A, and get some algebraic sums for the area and for x tutor A, y tutor A. Okay, so here is the table that we're gonna fill in. So first, let's take a look at the A, which is a rectangle, or sorry, is a triangle. So area A will be half of 3 times 3, so it's 4.5. Let's put the unit here, inch squared, so it will be 4.5. And B, area of B equals to 3 times 1, which is, it's not 1, sorry, it's 3 times 3 is 9 square inch. And A of C will be a quarter circle, so a quarter of pi r squared. So this will give us 9 pi over 4. And it's 7.07. And lastly, for D, A of D is a half or semicircle, so half of pi times 1 squared. And it's 1.57. So, but keep in mind that we're going to subtract the area of segment D or D. Therefore, you want to put a negative sign in front of this area to remind you that it's a hole that we need to subtract it from the sum. Next, let's find the centroid of each piece or each segment. Start from segment A, and we're looking for the centroid location, the x tutor and y tutor. So this is the x tutor and this is the y tutor. And now for the x tutor, again, the centroid for this rectangle or triangle located 1/3 from each side. So here 1/3, this distance to the x-axis will be 1/3 of 3. So y tutor is 1 here. And the distance from the centroid to the side of this triangle is 1. And then to the y-axis, you need to add a 3. So 1 plus 3 is 4. But we're looking for the coordinate of this point. So this is the origin, and this point centroid is to the right. Therefore, it has a negative x coordinate. So we should put -4 for the x tutor. Triangle A, the centroid is located 1/3 from each leg. So we're going to locate the C first. Let's say that's the centroid of triangle A, and we're looking for x tutor, or the coordinates of this centroid. So let me draw in a different color. We're looking at the distance from this point centroid point to the y-axis, which will be the x tutor, and to the x-axis, which will be the y tutor. So this is the y tutor, and that is the x tutor. And again, this point is located 1/3 from each side. So the vertical distance from the x-axis will be 1/3 of the overall height, which is 3. So this one is 1. Therefore, y tutor equals to 1. And the perpendicular distance to the side of this triangle is 1/3 of the base, which will be 1. But that's not the overall distance from the point to the y-axis. So we need to add the distance, or the length of this rectangle here. So x tutor equals to 1 plus 3. But also, we are looking at the coordinates of this point. And this point is located to the left of the y-axis. In other words, it's located on the negative side of the x-axis. So instead of +4, this x tutor should be -4, because it's located to the left of the origin. So again, be very careful with the sign here. X tutor is a -4 instead of a +4. Next, for this rectangle B, the centroid is located in the center, and the distance to the x-axis is half of 3, which is 1.5. So that is y tutor. So y tutor equals to 1.5. Now x tutor, same idea. The absolute value, the absolute distance from this centroid to the y-axis is half of 3, which is 1.5. But again, we are talking about the coordinates of this point. So this point is to the left of the origin, therefore it must be a -1.5. So x tutor is -1.5 for segment B. Segment C, for a quarter circle, the centroid is located at 4r over 3 pi distance from each side. So let me draw that distance first, and that's the centroid location. And the distance to the x-axis is 4r over 3 pi. So that's a very important formula that you're going to use in the future a lot when you doing analysis for beams or for shaft with a circular cross-sectional area. And the distance from C to the y-axis is also 4r over 3 pi. So this will give us the x tutor and the y tutor. So both x tutor and y tutor equals to 4 times r. R is 3 over 3 pi, which is 1.27. And you can also find the formula from the table in Canvas, the geometric property of those common shapes. So let's put in the numbers here. For segment C, both x tutor and y tutor are, should be positive. Both of the values are positive 1.27 inch. And last segment, segment D. And since it's the semicircular area, it has axis of symmetry, which is the y-axis. So the centroid must locate on the axis of symmetry. And the distance, vertical distance from the centroid to the x-axis is also 4r over 3 pi. So that means the x tutor is 0 since it's located on the y-axis, and the y tutor equals to 4r. R is 1 inch for this semicircle over 3 pi. And this will be 0.424 and is a positive y coordinate. And now we're ready to calculate the product of x tutor A, x tutor times A, and y tutor times A with the value we have here. Here, be very careful with the area D, which is a negative value. Not only when we calculate the sum of the areas, we need to subtract the value, but also when we use the A for other calculations, we also need to use the negative 1.57. And next, let's calculate the sum of the area. We just need to add this column, which will be 19.00, and add the x tutor times A column, which is negative 22.5, and add the y tutor times A column, which is 26.33. And now we're ready to plug the numbers we have here into the formula. So x bar equals to sum of x tutor A, which is negative 22.5, over sum of A, which is 19. And this will give us negative 1.18 inch. And y bar equals to 26.33 over sum of all the areas, which is 19. So this will give us 1.39 inch. And this problem is solved. So we can locate, and this one is easier for us to locate, the centroid of this composite area. So x equals to negative 1.18 is somewhere here, and y equals 1.39 is about the middle length. All right, so this is the centroid C of the composite area given.